Hey, I want to show you a texturing technique called Voronoi scattering that solves a couple common issues with texturing in Blender. The first is that image textures and procedural textures are hard to tie together. For example, it's really easy to add one image texture of a leaf onto a procedural ground. And of course you can just tile that around uniformly, but nobody really wants that. It's a much bigger challenge to scatter that around randomly. But tying in image textures to procedural textures like this can often give you the best of both worlds and give you better results than if you were to just use one technique or the other on their own. As an additional bonus, this scattering technique will also allow you to randomize tiled textures so that they don't look quite so obviously repeated, and it renders a lot faster than other methods of doing that same thing. I'm Jonathan Lampel with cgcookie.com, and in this video I'm going to show you exactly how Voronoi scattering works, as well as a few advanced methods that you can use to do some pretty cool things, like overlap neighboring images, or use tri-planar projection, so that you don't even have to UV unwrap your model. Unlike other node groups that you can just append in and use right away, like the advanced EV glass shader that I made in a previous video, this one works a little bit differently because it adjusts the texture coordinates before they get plugged into the image texture node, and then also adjusts the image afterwards, which means that the images themselves have to be buried pretty deep in the node network. And if you're scattering multiple images, there's actually a lot of setup that needs to be done pretty much every single time that you use it, and nobody wants to do that. So of course I used this opportunity to brush up on my Python skills, and I created an add-on called Scattershot, which does all of this for you in just one click. You have all of the advanced variations to choose between depending on your needs, and it'll also super finely tune all of the inputs so that they're really user-friendly. If you're already a cgcookie.com member, you can download this right now at no extra charge just by heading to the resources page. But if you're not a member, you can still get it using the link in the description below on the Blender Market. But in this video, I'm going to show you exactly how I set this up so that you can make it for yourself if you'd like. But I think by the end of the video, you'll see the value and the amount of time that it'll save just to be able to do this in one click. So let's head into Blender. The main concept here is actually pretty simple. We've talked about vectors and texture coordinates quite a bit in the Fundamentals of Texturing course, but the main important thing to know here is just that texture coordinates are x, y, z directions for where each pixel of a 2D image should appear on a three-dimensional model. When it comes to UVs, we only have two axes to work with, of course the U and the V, but in the node editor we can think about it as the X and the Y just to keep things simple. But if we hit tab to go into edit mode here, then we can see that this plane is kind of unwrapped over the entire UV space. And in UV space we have the 0 all the way down here on the x-axis, and then it goes all the way to 1 over here, and then it goes all the way to 1 at the top. So that's our normal UV space. And of course we can scale it, outside of that UV space, and so on and so forth, and we can also scale it down really, really small. Now what happens if we just pick a single point in UV space? Well, then it would just give us one single color. If we hit Shift A and go to Converter and combine XYZ, we can just plug in any number into here and have it pick that exact location in our UV space. So right now it's just 0, 0, 0, which is the bottom left, so we're going to get just complete black. However, if we set this to 0.5 and 0.5 for the X and Y, for the U and V, then we're going to get pure white. And that's just because that happens to be the middle of the image, kind of right in his eyeball somewhere in there. And if we just pick that exact location, then we're going to zoom in, all the way down to that exact pixel. And it's going to be even smaller than a pixel. So we're just going to get one single color. And this is where our Voronoi texture comes in and gets really interesting. So let's hit Shift A, Texture and Voronoi Texture. Let's plug the UV coordinates into the vector here. And we can look at this third position output here at the bottom. I'm using Control Shift because I'm using Node Wrangler to preview all of these sockets. Now this was added somewhat recently, I believe, by Omar Ahmed, if I'm getting that right, in his Google Summer of Code last year or maybe the year before. But this allows us to do some really interesting things. You can see that we're getting one single color of our UV coordinates per cell. So if I turn the randomness down, then you can see that every single one of these cells is just getting one color. Now if I plug this position output into the vector for our texture here, then we're going to get a nice pixelated version of our image. And as I scale this up, we'll just get more and more pixels. And this is kind of fun. It's a really cool effect. And if we increase the randomness, then we'll get a cool stained glass effect. And again, that's just because it's picking that one value in the middle of that cell and then applying it to the entire cell. Now, at the moment, we're getting a bunch of outlines that we don't want, and this is only something that's going to happen in Eevee. If we were using cycles, then that just doesn't happen. And that has to do with the pixel interpolation. So if we, for now, just go to our image texture and set the interpolation from linear to closest, then if we look at our UVs here, then it's not going to blend between our pixels at all, and we won't get that issue. However, if we set this to linear, you can see that it's trying to blend between them, but it's also trying to blend between the transparent and non-transparent areas, and so we get that kind of artifact. And this is more of an issue with PNGs, but I won't get into that. Just set this to closest, and you won't have that issue. Now, what we want to do here is not use the UV coordinates for the image, or use the position coordinates, but a combination of both of them. So I'll turn the randomness back down to 0, and the way that we want to do this, I'll set the scale to 1 as well. And what we want to do is make each cell its own 0 to 1 space. And the way that we do that is just find the difference between the UV coordinates and the Voronoi texture position. So Shift A, color and mix RGB. We can take the UV coordinates and the position coordinates and just subtract them. And when we do that, again, subtraction is finding the difference. Then we're going to get those X, Y, and Z gradients for each individual cell, which is really cool. So we can plug this into the vector here, and there we go, we have our cookie. But this is kind of weird because if we look at our texture here, we actually have 4 cells. And that's just because the scale is set to 1. If we were to start to increase or decrease this, it starts to look kind of weird. So first, let's get rid of some of the confusion by switching from repeat to clip so that we only get 1 cookie per cell. And notice that if I start to scale this up, then you'll start to notice that 0 in each of our cells is right in the middle, but 0 in our UV space is on the bottom left. So we just need to shift this over a bit in order to make it work. So right before we plug it into the image texture here, I'll hit Shift A and go to Vector and Mapping. And we can just shift this over in the X location by 0.5 and 0.5 in the Y as well. And there we go. Now we're getting just the center of the image. And we can change the scale here to change the individual scale of each of our cookies. We can also change the Z rotation here to change the individual rotation of each of the cells. So far this isn't hugely different than just tiling a regular image, but the fact that we're using a Voronoi texture gives us a lot of different interesting options, namely that we can randomize things per cell. So we have this color output, which gives us a random color, a random RGB value. So let's separate that out so we get 3 random values instead of just 1. So let's go Shift A, Converter, and separate RGB. And now we have a random color for the red, a random color for the green, and a random color for the blue. And we could use that to give a random location, rotation, or scale to each of our different cookies inside of each of these cells. So first let's do that for location. Now if we take this red value and just plug it straight into the location, then we've given the X, Y, and Z values a random value per cell. And so we've kind of shifted our logo around a little bit randomly. Now it's not entirely randomly because we have X, Y, and Z locations and they're all being given the exact same number. But if we want to give it a random Y location and a random X location separately, then we can hit Shift A, Converter, and let's combine X, Y, Z. And so maybe we give it the red value for the random X location and the green value for the random Y location. But there is no Z location, of course, in the UV space, so that doesn't matter. So this is pretty cool, but maybe we don't always want it to have a random location, so we can just blend between this and the original values. So I'll hit Shift D to duplicate this, and before we had 0.5 for all of these, and then we can just mix between the two. So I'll hit Shift A, Color, and Mix RGB, and we'll mix between these two. And if we have a value of 0, then we'll get random. A value of 1, we get not random. So I'll actually just switch these around because it's a little bit more intuitive for 0 to be not random. And now we have a control for our random location of each of our cells. And that's pretty cool. And then if I wanted to increase or decrease how much this is moved along the X or Y axes, then I could just multiply these values before they go into the combine XYZ node. So if I go Shift A, Converter, and Math, and let's say I want it to move a little bit more on the X-axis, then I could just multiply by a value greater than 1. So if I want it to move quite a lot, which in this case just kind of moves it straight off the cell and we can't see it anymore. But if I wanted to do that, for example, then I could just multiply that. Or if I wanted to move it less, for example, to keep it inside the cell, then I could make that less than 1 or 0.5. So if I Shift D and do that for both the X and the Y, then we can kind of cap the maximum amount of allowed movement so that it stays roughly within the cell. I don't really want to worry about that too much, but I just wanted to show how you could adjust that to your liking if you want to. So here we have the random location. Maybe I'll move this off to the side here, or separate this out a little bit. Just to keep things organized, I'll take this and I'll hit Shift P and parent that to a little frame there. I'll hit N on my sidebar, and I'll call this random location. Okay, so we can do the exact same thing, but for the rotation and the scale as well. But right now we only have one random value left, but we may as well just use that for the rotation. So we can just change the rotation by changing the Z value here. And we might need to rotate it before changing the location. Because if we rotate it here, that's rotating it from the center of the cookie. But as soon as we shift it and then rotate it, then it's not rotating based on the center of the cookie. So I'm going to separate this out. So instead of using a mapping node here for everything, I'll just change this into a bunch of different vector nodes. So in order to move something, all we need to do is just add or subtract from the vector. So if I hit Shift A and go to Converter and Vector Math, and just use an add node instead of a mapping node, let's say we're using this as the vector, and then this as the resulting location. Then we can plug this into the cookie logo, and there we go. Okay, so we still need to scale it, but I'll call this node location. And at the moment, I'll set it to 0, so we're just looking at right at the center. And then let's add our scaling back in so we can actually see what we're working with here. And to scale something, we just need to multiply the vector. Or we could actually just use the scale function and do it just with one number here. So as I increase the scale, and then it'll scale it up and down. But again, we need to do that before that final shift over, before that 0.5 shift. So let's do that over here. And we can get rid of that mapping node. So if we do that beforehand, then we can scale it right from the center. Okay, so I'll call this scale. And then we also want our rotation. And I don't think it matters whether or not that's before or after the scale. I don't believe there's a vector rotate function here, so let's just use a mapping node for that. Shift A, vector, and mapping. Let's plug it between the scale and the location. And if we just change the Z rotation, then it'll rotate it right from the center, regardless of the scale. So once we've organized these things into the right order, I'll call this one rotation. So I'll take a converter and separate XYZ, or actually combine XYZ, excuse me. And that way we can just change this single Z value without messing anything else up. And let's say we want to give this a random rotation. So we can use this last number and plug that into the Z. But instead of going from 0 to 1, we want to go from 0 to 6.5. So let's hit Shift A, converter, and map range. And we're coming from a range of 0 to 1 to 0 to 6.5. And there we go. Now we've given it a random rotation. But maybe we want to control over how much random rotation, so we can just use another color and mix node for that. So I can just Shift A, color, and mix RGB. And we can mix this with 0. So the first color is going to be black, or 0, 0, 0. And then number 1 is going to be that random rotation. So here we have a control for that. So I'll hit Shift P, create another frame here, and I'll call this random rotation. And now we have to get a random scale as well. And we'll do this the exact same way, but we've kind of run out of random values to use. But that's okay, we can still use a white noise texture for that. So let's hit Shift A, go to Texture and White Noise, and if we plug this random color into the vector of the white noise texture, then we can just continue getting as many random values as we want from the Voronoi texture node. So if I hit Shift D, plug this into here, then we will get the same value for every white noise texture that we have. But if we set this to 4D and give this another W, then we can just get as many random values as we need. But for now, we don't need to change the W there. So let's just use this value. And we don't need all 3 dimensions, so let's set this to 2D instead, so it'll be slightly faster. And we just need the value, not the color. So we need to find out what scales we want to go between. And let's just say we want to scale these all uniformly. So instead of worrying about the X, Y, and Z directions, I'm just going to just plug in one value for all of them. So if we go to input and value, let's find the smallest value that we want these to be. And it looks like 0.5 is probably pretty good, because if we go all the way to 0, then again, we're just scaling it super far in, all the way to 1 single pixel. We don't really need that. So let's say a minimum of about 0.5, maybe even 0.75. Let's go with 0.5. And let's say the maximum should be about 1.5. So in order to get those values, all we need to do is just hit Shift A, go to Converter and Map Range, plug the value into the value. We already know we're going from 0 to 1, but we want to go to a minimum of 0.5 and a maximum of, I already forgot, what was it, 2, something like that. And we can plug that into the scale. And now we have a random scale for each one of these. And of course, we might want to mix between this and no change whatsoever. So I'll Shift D on this node here, Alt P to clear that parent, to remove it from the frame node. And then we can mix if we set color 1 to 1. That'll just be the original scale. And then we can switch between the original scale and the randomized scale. So here we have a control for random location, random rotation, and random scale, which is pretty cool. If we were to make this into a group node now, all we would need to do is just plug these values into the inputs here. Just to keep things organized, I'll select these bottom nodes, hit Shift P, and call it random scale. And the way that we've set this up is pretty good, because we already have the scale going into this node here. And so we can scale it individually and then apply that randomness on top of that, regardless of what this scale is. So this setup works pretty well. And then we could just take this and let's make this just one big group node. So that we don't have 2 inputs for the UVs, I'll just Shift and right click and drag to create a reroute node, and then select everything leading up to the image texture but not including it, and hit Control and G to make that a group node. I'll hit Control Tab to back out of that, and I'll just call this scatter coordinates. And the reason that we're leaving the UVs out of this for now will become apparent in just a minute. So we have our scatter coordinates. We could also put in all of the options that we might want outside of the node, kind of plug that in. So let's say we want our scale. Now if we change the scale on our Voronoi texture here, then it's not going to scale the actual cookie with it. So we don't want that. We actually want to scale it beforehand. So I'll just set this to 1 here to keep things simple, and I'll set this scale over here to 1 as well. And instead, I'll Shift D on this scale over on the right and bring it all the way over here at the beginning so we can scale everything all at once. So I'll plug this into the group input, and I'll call this pattern scale, since it scales the overall pattern. And then over here, with this scale, I'll call this one the individual scale. Oh, and it looks like I renamed the wrong thing. Okay, so let's look at our node, and this one I'll call pattern scale, and this one I'll call individual scale. And we want to make sure that the defaults for these are just 1 and 1. We just want to make sure that it's not 0, because otherwise we'll get confusing results. And then let's see what other controls we might want. We might want the randomness value here to control how much of the Voronoi random cell shape we're getting. So I'll just plug this, I'll set that to 0, plug that into the group input, and I'll call this random cell shape. And we might need a little bit more room to work here. And then we can also plug in our random values. So we have our random location, our random rotation, and we have our random scale. And already we have a pretty interesting node to work with. And what's cool about this is that it renders very quickly. Now, one issue that you might see as you're working with this, as you change the random location and the random scale, is that it's kind of getting cut off right at the edges of our Voronoi cells. Now, there are two ways that we could go about fixing this. The first way is to kind of blur the edges of the Voronoi cells a little bit, which is kind of a cheap and hacky way to go, but it renders very quickly and it kind of disguises the issue. And then the other method is actually enabling overlap of neighboring cells, which is a lot more complicated. So let's do that one second. So let's go into our scatter coordinates here. And let's just scatter the UV coordinates before they get plugged into the Voronoi texture. Now, we don't want to mess with the coordinates for the overall image texture because we don't want that to get moved around at all. We just want to scatter the coordinates for the Voronoi texture itself. So let me show you what I mean. If we hit Shift A and go to Color and Mix RGB, and mix between a color here, we can change kind of where these cells are being placed, but we're not changing the actual location of the image itself. So this is what happens when we adjust the coordinates of the Voronoi texture, but not the image. So that's kind of cool. But what happens if we add a noise? So in this case, let's add a white noise texture. Shift A, Texture, and White Noise. Let's just use our UV coordinates for that. And we don't need it to be 3D, so whenever possible, let's use 2D, just because we're going to be using a lot of nodes here and we want it to be as light as possible. And for that reason, we may as well switch our Voronoi texture to 2D. But okay, let's take our white noise texture here and plug the color into the color 2. So now as we're mixing between these two, we're kind of shifting the values of our coordinates towards the white noise texture. So it kind of blurs the edges, but it also scales everything up as we're going. And you can see that a little bit better here. If we look at the color, it blurs it, but it also shifts it kind of up and to the right and kind of scales it up. And we don't want that. So the magic formula here is to use linear light, which is going to blur the edges. It's going to kind of move all of our coordinates in a random direction without scaling it up. So if we switch over to linear light, then we can just change this factor here and kind of blur those edges. So that can be incredibly helpful. So I'll just plug this factor right over here, and I'll call this edge blur. And right now it's not particularly a user-friendly value, but that's okay. We can just work in small increments here. And if we look at the cookie logo, then as I increase this edge blur, then we're going to get an effect of, kind of overlapping these guys. So it's not a perfect solution. Again, it's, still kind of cutting it off rather abruptly, but it is better than nothing, especially if you have the random cell shape. Then just adding a little bit of edge blur kind of helps blend it into the background. This is especially helpful if you have repeating textures, for example, a ground texture that is, you're not going to see any background, but is all just kind of laying on top of each other. Then this can help kind of blend the edges between those, so it's not quite as obvious where the seams are. Now, another thing that we could do is warp the edges, which is pretty interesting. So let's say we don't have any edge blur, but we want the edges of our Voronoi cells here to be a bit less obvious. And let's just change the individual scale so it's super obvious where the seams are. We can do this same thing, but instead of blurring the edges, we can warp it with a regular noise. So I can hit Shift D and duplicate this linear light, and to just name things well, I'll go to Item, and for the first one I'll call this Edge Blur, and for this second one I'll call it Edge Warp. And we can do the exact same thing but with a noise instead. So Shift A, Texture, and let's just use a noise, plug the color into the color, and plug the vector into the vector, and we can change the scale. Let's turn the scale up a little bit, and then the more linear light we add, the more these edges are going to get warped. So it's just kind of breaking up the straight lines that we see, so that as we're kind of scattering our texture, it's going to be less obvious where those seams are. So maybe I'll take that. And we don't need this to be 3D, we can change that to 2D. We don't need quite so much detail. Maybe I'll change that to 1, just to make this as fast to render as possible. We can turn the roughness up a bit. And then we can call this Edge Warp. So I'll go to Node and rename that input. And there we go. So even with just this setup, this is enough to really scatter around a nice ground texture. So let me just find one of those really quick. Where if we were to just tile it, I'll hit Control T with Node Wrangler enabled and change the scale. Then we can see that this looks obviously tiled and just doesn't, we wouldn't want to apply this to a wall in the background. However, if instead we take our scatter coordinates and just plug that in and scatter this around, then this starts to look a lot better, and we can change all these values accordingly. So let's just reset it really quick. Let's change the individual scale to 1. Random cell shape, we can keep that at 1. That looks great. We can change the random location, which is interesting. So this is why you might want to increase the amount of random location. Right now we've decreased it. If we go up here, we've multiplied by 0.5. So let's multiply this by 2 instead. So we get a much larger area that it'll travel between. And then if we kind of zoom in a little bit for the texture and then increase the random location, essentially it's just picking a random spot in the texture to show up in this cell, so that not each cell has the same part of the texture in it. And then we can change the random rotation here. And it still looks, pretty decent, but it still looks somewhat repeated, and you can kind of tell where the edges of those cells are. If we change the pattern scale, this looks better, but it's still not quite right. However, if we warp those edges a little bit, then things start to look a bit better. So if we make it, less obvious that those are straight lines, and maybe we'll want to go in here and change the scale of the warp, or you might want to make this control on the outside of the node, but we can change the scale there and kind of warp this around, and then it's kind of less obvious exactly where those seams are. And then we can go the final step. If we zoom in here and find one of those seams, you can see this right kind of over here, we can just take the edge blur and kind of blur that out a little bit. Now, one thing that's interesting is that it's kind of blurring it out a little bit too much. You can see that we're just getting kind of the average color kind of spread out. And again, this is due to the pixel interpolation. And this one I'm not entirely sure why, but again, we need to set our textures to closest in order for this to work well. And now you can see that this is actually blurring quite nicely and kind of covering up these edges a bit. So it's less obvious where they are. And then when we zoom out, then we have a nice, not obviously repeated pattern. Now this same setup is pretty much exactly what's going on in the add-on version of the node. So I'll show you that here. If I just Shift D and duplicate this, if you've installed the add-on, you can find it under Node and go all the way to the bottom and Voronoi Scatter. And if you right click and assign to quick favorites, then I can just very quickly hit Q and Voronoi Scatter. And then we have all of these different options here. So right now let's just look at UV Simple, which is the method that we just created. Grouping is interspersed, we'll look at that in a bit. Pixel interpolation, we want to set that to closest. Image extrapolation, we can set that to repeat. I think by default it is clip. And then we can turn on these other random options, which just randomize this just a little bit more. So then we can look at the result here, and we can do that exact same thing, but it just does all of the work for us. So we can change the pattern scale, the individual scale, and then we can change the individual scale X, just in case it's not a square texture. And then we have our individual rotation, just in case we need it. But then we have our random location, our random rotation, and our random scale. And I've tried to fine tune these values to be pretty intuitive for no matter what texture you're working with. But then we also have a random hue control, a random saturation, and a random value. So let's turn the random value up just so that we can see where our cells are at the moment. And we can give this a random cell shape. And then I've also included a texture warp, which does the same thing, but just warps it right at the end, just in case you want to give each object in each cell kind of a random shape. Like example, if you're scattering a bunch of flowers and you don't want each flower to be exactly round, then you can use the texture warp and just give it kind of an overall warp so that each section is just slightly different. And in this case, I'll leave that off. Then we have our edge warp here. I can increase the scale and maybe make it a little bit less extreme. Let's go something like that. And then we have our edge blur. And then I have an option for alpha clip in case you're using transparent textures that aren't quite created correctly and you need to kind of clip off the ends there. And then a random seed, just in case you need that. So here we already have a pretty cool group node that we could drag and drop into any file. And as it is now, it works really well for terrains and very simple things. And it actually also works with box mapping. But we need to change a couple things in order to get that to work. So I also have a Suzanne here, and I'll hide the plane and kind of zoom in, and right now it's still assigned to the UVs, but we could just switch this to object coordinates, and that'll kind of project it from the top. But then we need to go to the image texture itself and set this from flat to box. And so now this works with box mapping, but you'll notice that it's very stretched, and that's because we can't rotate the coordinates before a box mapped image. So we actually have to take our random rotation and turn that all the way off, otherwise this just won't work. But we can change the pattern scale, and everything else pretty much works accordingly. The only thing that we do need to change though inside the node itself is to switch our textures to 3D, because we're now using that Z direction. So we have to change that little optimization. So we need to change our noise texture here, because you can see that it's stretched along our Z axis. We need to switch that to 3D, and we need to do the same for our Voronoi texture here, 3D. Now we don't need to do that for our white noise texture, because it's just kind of picking a random color per pixel of our screen, so it doesn't really matter whether that's 2D or 3D. But now we have this working correctly for box mapping, and we can use our box mapping blend and everything like that. Now if you're just doing this for one image, then this works great. But the reason that my other node setups were so complicated is I wanted to incorporate scattering a bunch of image textures around, not just one at a time. And that's where things get a little bit more complicated, but not as much as it might appear if you just look at the node graph itself, because we're actually just doing the same thing over and over again. So let's take a look at a different example. Instead of just mixing kind of one background texture like this, let's take these coordinates in the scatter coordinates node, Shift D and duplicate them up, and let's move this setup kind of off to the side here and kind of forget about it for now. We can always come back to it later, but let's just use our UV coordinates here, plug this into our cookie logo, and kind of reset everything. And let's look at our plane as well. So let's go to top view here and kind of reset everything. Let's take our randomness all the way down for all of these values and turn the individual scale back to 1 or even a little bit higher here. And let's say that we want to pick a random image per cell. Now that'd be pretty easy actually, because we have a random color that comes out of the Voronoi texture. We just need it outside of this scatter coordinates node. So let's hit tab to go into the scatter coordinates and just take this Voronoi texture color here and plug this into the group output. And we just need to rename this random color. Then I'll hit Control Tab to go back out of that. And now we can see that we have a random color per cell. So we just need to use that to switch between a bunch of different textures. So I'll bring in a couple different images, and for this example I'm using transparency so that we can learn how to overlap them in just a second. But let's say we have our cookie logo here. Let's also use Blender community logo, or it's like a little badge like that. We can plug the vector into the vector there, and now we have this scattered around. But of course we always need to set this to clip if we're using transparency, and also set the interpolation to closest to get rid of those kind of jagged lines in between the cells in Eevee. And then we also have a Blender Market logo here. Let's plug the vector into the vector. Now set it from linear to closest. Okay, and part of the reason I created the add-on was so that I didn't have to think about all of these things every single time. Let's say that we have all of these three scattered around, and we want to randomly pick between which one is in each cell. Well, since we have the random color, then we just need to find a range of values that we can easily find which one should fit in which set of values. So a map range node is perfect for that. So let's hit Shift A, Converter, and Map Range. And right now we know that any color that's coming out of this is somewhere between 0 and 1 in terms of value. So if we plug this into the value here, then the output is going to be kind of a grayscale version of that random color, but between 0 and 1. But we actually want it to be between 0 and however many images we have. In this case, 3. So let's just set the max to 3 here. And then we can definitely say that anything that is between 0 and 1 should be the first image. Anything that's between 1 and 2 should be the second image. And anything that's between 2 and 3 should be the very last image. And we can do that using a math node. So let's hit Shift A, Converter, and Math. And let's say that anything that is greater than, let's plug in this value here. Anything that's greater than a value of 1 should be the second image. So we just need to use this to blend or mix between these two images. So Shift A, Color, and Mix RGB. Plug the color into color 1, second one into color 2, and just use this as the factor. And there we go. So now we just need to do this same thing, but with the result of that and the third image, but this time using a greater than of 2. So Control-Shift-D to duplicate this over. And I'll kind of stack this on top here. And this time we're going to use anything that's greater than 2 and plug this into the factor here. And so now we're just randomly picking an image for each cell. And if we had more images, then we just need to increase this map range to maximum number. And you can also use this to kind of drive how many of which image is selected if you want. But I'll set that to 3. And in the add-on version, this is all just automated with Python so that it just happens automatically. But coming up, we're also going to need to do some operations using the alpha of the image itself. So we need not just the color output, but we also need the final alpha output. Because right now, we are getting the color, but everything in the background is just black, and maybe we want to change the background or do something else. Each of these images need to have their own alpha output. So let's just take these nodes here, Control-Shift-D to duplicate while keeping the connections, and then instead of plugging in the color, we can just plug in the alphas. Now as soon as we do that, then you'll notice that as soon as we actually use the alpha here, then it's going to switch to using straight alpha, and we're going to get kind of an incorrect color for the color output. Now that's not that big of a deal because we can always just multiply that with the alpha, kind of at the end, Shift-A color and mix RGB. Take this and multiply, like so. Or we could set the images themselves to use pre-multiplied alpha. So that's exactly what that means, is just multiplied beforehand. But I'll leave this here at the end. But if you want to do that, then you can just go to your image here, hit N to go to the sidebar, go to image, and under alpha, you can see it's set to straight. If you set this to pre-multiply, then that's exactly what it's going to do. You can see here that comes up as black. But I'll just leave that as straight so it calculates nice and fast, and then we can just do the multiplication all at once here at the end. Alright, so we have our color output and we have our alpha output down here. Now, it's also very helpful to have a random color output as well for each of these in their individual shapes, and that'll come into play in a little bit when we start to layer these images on top of each other. So let's just build that in now so that we can use that in just a second. But first, let's make this into one big group node, because in order for the layering to work, in order for us to change the random location and have these actually overlap each other, then we're going to need to duplicate this around a whole bunch. And I don't want to duplicate this giant setup here. I'd rather just have this all as one kind of condensed node and use it throughout. And that way, if we need to switch out our images or anything, we can just do that in one place, and then it'll just kind of happen naturally everywhere else in the node graph. So in order to do that, I'm going to shift and a right click and kind of combine all of these different vector inputs here, just so that it doesn't create a bunch of inputs for a group. And then I'll hit Control-G while selecting all these nodes to create a nice group. Then I'll hit Control-Tab to go out of that. And I'm going to call this one Scattering Source, because it's the source images for our scatter. And I'll hit Tab to go back into that. And let's just kind of switch around these values really quick so that they are plugged in order outside. So we have the vector, and then we also have the value, which is being plugged in here, but it's not really the value, it's more the random color. So I'll just call that random. And it is more of a factor, it's not really a color, so I'll just call it random, like so. And then we also need a alpha output and a random color output. So we have our basic color output, but then we also have this one as our alpha output. Then we also need a random color output. So we have our random color going in, though right now it's actually, since it's connected to the value, it is actually inputting the color, even though the socket's gray, so that's a little bit confusing, but it's still actually giving us the full color, so that's nice. But we can take that and just multiply that with the alpha, kind of like we did with the color. So I'll hit Control-Shift-D, but instead of using the color as the color 1, I'll use the random color here, and that way we're getting kind of a random color that's only assigned to where the actual image is and not in the transparent areas. And that'll kind of help us in just a bit. So I'll plug this into, actually I can just rename our viewer node here since we're looking at it. I'll just double click and rename this to, let's call it random color, like so. And once I rename that, then it's not going to go away as soon as I hit Control Shift and preview something else. So we have our color, we have our alpha, and we have our random color. So here's where things get interesting and where we can actually overlap things on top of each other. And the idea for this actually came from Twitter, from following Gabe, and I saw that he had been able to overlap his scattering, and I was super curious how he did that, and he actually explained that you just need to check kind of every cell that goes around each image. And so I was able to figure that out, but it was thanks to following him on Twitter. So if you want more node tips, I'd recommend checking him out. And there's just a whole bunch of great procedural node people on Twitter that are very, very helpful. And I would definitely recommend getting involved in that community if you want those cool little tips. So here we have our scatter coordinates, and let's just increase the random location and kind of define exactly what we want to do. So let's take a look at this example here, where we have our cookie logo on the left, we have the Blender logo on the right, and they're kind of just getting sliced right in half. But we actually want the rest of this Blender logo to kind of be drawn behind this cookie, and the rest of the cookie to be drawn on top of the Blender logo. And the way that we do that is we shift over the cell that is looking at the Blender logo itself and kind of layering that underneath the cookie. So let's just do that in the scatter coordinates, and then as I do it, it'll make more sense. So hit Tab to go into that, and then we can easily move around the entire texture just by altering the location right after this pattern scale here. So I'll shift and right click just to create a connection here, so we're only working with one. Hit G and then X to move that over. And let's use just a vector add, because remember, add is going to translate things, whereas multiply is going to scale them. So let's go to converter and vector math, just so we don't have to add just a whole mapping node. And you can see by just kind of shifting around these coordinates, we can shift around the entire texture. So this is pretty easy. But what we also need to do is shift our images back in the opposite direction in order to kind of reset where it is. And so by manipulating both of those values at the same time, then it'll look as if the cells themselves are shifting without actually moving the texture. So I can get rid of that reroute node there. And let's do that over here before it gets plugged into this scale. Because if we were to do this, I'll just hit Shift D, and if we were to do this kind of at the very end or change any of the locations like on the rotation node here, then if we have a random rotation, for example, let's give it a random rotation. If we were to move it now, then you can see that it's moving in accordance with that rotation because the rotation is happening first. So we need this movement to happen before any of that. So I'll plug it in before the scale here. And I'll call this node, just to keep things labeled, I'll call this shift back, I suppose. And then I'll call this one shift. Okay, so we just need to do the opposite of whatever we're doing here. So instead of moving it along the, let's just say 0.5 in the X direction, we actually need to subtract that same value, 0.5 in the X direction. And so if we were to move both of these values at the same time, it would appear as if the cells themselves are shifting. So we just need to plug this kind of into the output, and then we can use that same value in both. Plug the vector there, plug the vector here, and then in the node itself, under the inputs, I'm going to call this just shift, and the defaults will be 0, 0, 0. So now if we go outside our node here, we're moving the entire texture and then moving what's inside the cells over in the opposite direction. So the appearance is that we're shifting over the cells themselves, and we're kind of like looking through a window to our texture. So what we need to do now is just take this and kind of shift it over and check each individual cell. So if we have our random color here, let's say we're looking at this cell here, then we just need to check this little grid block there, this grid block here, this one, this one, this one, this one, and this one, and layer them all on top of each other. So it's not going to be entirely perfect because at some point it's going to need to kind of cut off from the start of one to the end of the other. So there will be kind of one corner at which it's not going to quite work, but for the rest it'll look very convincing. So what we need to do is just take our texture here and duplicate it down. I'll hit Control-Shift-D to duplicate while keeping the connections, and I'll kind of just stack these in a diagonal line. And let's say we need to take this and move it, let's move it over to the right one. So that looks like it's taking it one in the x-axis here, or excuse me, over to the left one. And now we can see that if we zoom in really close here on our Blender logo, we get kind of the right half, and then we get the left half. And now we just need to layer these on top of each other. And we can just do that with the mix node and using the alpha. So we just need to hit Shift A, color, and mix RGB. Plug the color 1 into color 1, color 2 into color 2. And then we need to use the alpha of the first one. So let's take the alpha and use that as the factor. But that's going to give us the kind of inverse of what we want. That'll give us the opposite. But if we just switch these colors around, then we'll get exactly what we need. So here's before and here's after. And we're kind of just completing that picture to the grid off to the left. And let's see if we have any examples where it is overlapping. Here one example here. We get before and after. So we're just layering it over. And so that's very cool. But we also need to do this for the random color as well. So the way that we do that is just Shift D this mix node, so that we can apply any random operations after the fact. Then we also need the resulting random color. So let's plug this as color 2, this one as color 1, and again use this alpha as the factor. Okay, cool. So we have the colors, and here we have the random colors. Now, when I was doing this the first time, because you have to duplicate this setup a whole bunch of times, it actually gets a little bit confusing which ones you're plugging into which, and I just found that to be a little bit aggravating. Now, at this point, we also need an alpha output so that we can combine this with the next iteration. And I found a quick way to do that is to just use the color output here and find everything that's greater than 0. So if we just do Shift A, Converter, and Math, and just use a greater than, and 0, then anything that's more than black will be considered white. And here we have our alpha for the overlap. Now if we set this to be more than 1, that's more of like the alpha clip, but I'll just set that to 0 there. And in order to actually get these nodes to line up more so that it makes sense what I'm plugging into what, because I'm going to have to be doing this a whole bunch of times, then what I'll do is I'll just hit Control G to make this a group, and I'll call this a scattering layer, like so, and then I'll just rearrange these sockets and label them so that they make sense. So we have first, it looks like, I'll just kind of look at the background here, we have the color for the first image, and that is being plugged in at the top, so I'll call this color 1, and then what's being plugged in next is actually the alpha value, and it's being plugged in multiple places, so we can actually just get rid of this one here and use the factor down there as well, but we'll call this alpha 1. And then third, we have the random color, but it should be plugged in third instead of fourth, so let's just bump that up a bit and call this random 1, just to be clear. And then we have our color 1 down here, which should be called color 2, and then we have our random 2. And then for our outputs, we of course need our color. So let's bump that up to the top spot. And then we have our alpha, which is the value. Let's just rename that alpha. And then we have our random color result. So let's call that random color and bump that up to spot number 2. So now these all plug into each other very nicely, and we can just duplicate this setup and continue moving all the way around. So I'll do it one more time, and then I'll just finish the rest very quickly so that we don't have to sit through the entire thing. But if we just take these 3 nodes, Control Shift D, and duplicate this down, and then instead of using, of course, the results from the first one, then we can just plug in the color here, the random, and the alpha. And it looks like I need to switch these around under here. So let's take the alpha, move that up to spot 2, and there we go. Now it looks all nice and clean, and we can look at the result. Of course, it's going to definitely take a second because we're layering so many things on top of each other. But now instead of just going one over to the left, now we need to go to the left and up a bit. So let's take a look at this result here and move this up along the y-axis. So it looks like that needs to be a -1. So you can barely see that part of the cookie logo, but let's take a look at some other areas. And now we can see that the result here is all 3 of those combined. So if we take a look like right here, and here we have the first version, second version with a bit more layering, and then number 3. So we just need to do this for every single cell that's going around. And this is definitely going to take a little bit more time to compile for sure. When you're using Eevee, it'll be a little bit faster in cycles, I believe, but with Eevee it will be a little bit slower. But it's a very cool effect, and I think it can definitely be useful sometimes. Once we have this whole system set up, then we can just combine it into one single group node like I've done here. So I'll hit tab to go into it, and you can see we have this exact same setup, but I've just created a group input here and connected it to every single one of these nodes. And then for the output, I just have the color and the random color going to the group output. So now we can change all of these controls and it'll adjust everything accordingly. So we can change the pattern scale, individual scale, random location, rotation, and all that stuff, and it just happens to work. You can see here if we change the scale, then we're starting to get that nice overlap. There's a couple areas where it does kind of cut into the other textures, but for the most part it looks quite good. There is one change that I did make from earlier, because as I went through this while recording for this tutorial, I did it slightly differently than the way I built it for the add-on. And there was one thing that kind of bugged me in particular, and I did a couple things slightly differently just because I was going off of memory. But in the scatter coordinates, I had, actually the version I just showed, I had you shift everything over according to the shift right after going from the pattern scale, and then shifting it back way over here. And that does work, but that is kind of wasteful because I forgot that you could just shift things only going into the Voronoi texture without shifting everything that's going over to the location. So that's what I did. You can see here I've gotten rid of that shift node over here and gotten rid of the shift node over here, and instead we're just shifting these coordinates down here. And you will notice that as I make changes here, this does take a pretty good long while to compile, because it's of course scattering 3 individual reasonably high resolution images 9 times, and so this is fairly slow. But as you can see, if I just shift things before they go into the Voronoi texture, but not when they go into the subtract node here, then it's going to do exactly the same thing. So instead of needing to do 2 operations to get that, then we can just do 1. Alright, so we've almost come to the end of all of the basics of what's going on here, but there's one other piece of the puzzle, and that's tri-planar mapping. Because before we looked at box mapping, and we saw that it does indeed work on our textures here, but unfortunately we can't use the random rotation, just because if we try to rotate any box map texture, you can see that doesn't work even with a normal texture setup. Actually, let's just Shift D and hit Control T. And you can see that if we set this to object and box map, if we try to rotate this anyway, you'll see that the same thing starts to happen. So nothing really we can do about that. However, we can use our own custom tri-planar mapping instead. And this is something, again, that I did not come up with. This is also one of those things that I will credit to Gabe on Twitter. He just randomly posted it out of the blue, and that happened to be exactly what I was looking for. So again, go thank him on Twitter, get his stuff on Gumroad, and tell him to post that stuff to the Blender Market too. But definitely go support him there. So we're going to build that setup here, but it's useful for not just this, but also for all sorts of procedural textures and things like that. But that'll allow us to use our random rotation, scale it along the X, and anything else that we need to do. Here's how this works, and we can test this out on an image texture before we apply it to our node. So I'll just take our concrete rough here, Shift D to duplicate this over, and set this back to flat. So if we were trying to use our object coordinates here, it's going to be stretched along the Z-axis. So let's see if we can get rid of this. Well, the main concept here is that we want to kind of project from all sides of our object. The top and side and the front and so on and so forth. So we need to know at least the normal, or which directions these faces are pointing. So let's get that first. We can see that under the texture coordinate, right under normal. Now what we need to do is separate this out into the X, Y, and Z axes. So that's pretty easy. We can just go to convert and separate X, Y, Z. And, oh, not that. We need to plug that into the normal. And here we can see the normal along the X, along the Y, and along the Z. But of course we don't want to just project this from the top, we also need it coming through from the bottom. So we actually need to find the absolute of this, so all of the negative numbers as well, just not the 0. So we can do that with a math node, so Shift A, converter, and math. We can go to absolute, and here we get the top and the bottom. And we can do this for all of our X, Y, and Z axes, but we could also just do it all at once with a vector node. So let's do Shift A, converter, and this time let's use a vector math, and do the same operation. Let's use absolute. And what this is doing is just doing that exact same operation for all 3 axes at once, so we don't have as many nodes to worry about. So now we have this for the X and the Y and the Z. Now the thing that we have to do is find where on the model one of these axes should start and the other one should stop, based on the angle. Now the clever trick here that I was having trouble with is to use the less than node. So let's hit Shift A, Converter, and Math. So let's set this to less than, and let's plug in our X to the first one, and then our Y into the second one. Now if we unplug the threshold, just so we can see this, we can find exactly where we want this to start and stop, but I just hadn't even considered plugging in the Y value here as the other option. Now this is going to give us some strange cross sections on our Z-axis, but remember we have our Z-axis separate, and so we actually don't need to worry about that because we can plug that in last and kind of overlay that area. So what we need is 3 of these different versions, one for the X-axis, one for the Y-axis, and one for the Z-axis. So here we have one that blends for the X-axis. I'll hit Control-Shift-D, duplicate this, and this one will be blending between the X and the Z. Just like so. And then Control-Shift-D one more time, and this one will be between the Y and the Z. Now you might think we need to find every single variation of the XYZ combination, but what we can actually do here is just use a color and mix RGB node. So Shift A, color, and mix RGB. And first let's mix between X and Y. So I'll plug the first one into the factor here. And let's make X red, and Y should be green. But you'll notice that the only parts that have problems are the parts that are along the Z-axis. And we can get that Z-axis by actually just multiplying these two together. Because everywhere where it's black on one should also be black on the other. So let's just Shift-D this mix node, combine these two, and just multiply them together. So we're placing this one last because it just kind of covers up all of the weirdness on this top one along that Z-axis. And then we can hit Shift-D and combine this result with our blue, which is going to be our Z-axis. So plug this one in as the factor. And there we go. We have our X, Y, and Z axes here, but now we need a way to blend these together. And the way that we do that is exactly the same way as we blended the seams before, is with a white noise texture. So let's do that before we plug this into the absolute. Let's just use a Shift A, color, and mix RGB. Just like before, we'll use linear light. Shift A, texture, and white noise. We'll use the same coordinates that we're using for everything else. And we can plug the color into color 2. There we go. And now we have a way to blend between these. We don't need this to be 3D, so I'll just set it to 2D. So we have our colors here for the X, Y, and Z axes, but what we don't have is a way to directly apply this to the image. If we look at our flat image texture here, you'll notice that the only time that it looks correct is when we're looking from top view, because it's stretched along the Z axis. But if we're looking directly on the plane that has the X and the Y axes, then everything looks correct. So now we just need to shift those X and Y coordinates and pretend that that's coming from the side and that's coming from the front as well. And if we do that, then we'll have our triplanar blending. So what we need to do here is actually just separate our X, Y, and Z axes again. I'll do that over here. We don't need the absolute for that. So I'll just plug in our object coordinates. So we have our X object coordinates, our Y, and our Z here. And now we just need to switch these around to tell Blender that actually from every side, they're just the X and Y coordinates. So what we need to do is have a combine XYZ, Shift A, converter, and combine XYZ. And for all of these, our Z is going to be 0 because that's the axis that's not really helping us out here. So we're just going to create all of the other combinations. To create our X-axis, we'll go for the Y and the Z. Then I'll Shift D to duplicate this down. And then for the Y-axis, we'll plug in the X and the Z. and then Shift D one more time, and then for the Z axis, we'll plug in the X and the Y. Okay, so now I just need to plug these into the nodes that we've created before, where instead of using our red, green, and blue, we're using these different coordinates. So now we'll plug the one for the X-axis into color 1, the one for the Y-axis into color 2, and the one for the Z-axis all the way over here where the blue was. And here we have our coordinates. It doesn't look like much, but if we plug this into our image here, then we should get a nice box mapped texture. So we can still do all of the things that we need to here. We can go ahead and scale things beforehand. Can't really scale it afterwards. But if we take a converter and vector math, and let's set this to scale, then we can scale the texture, and you'll see that the seams are going right along where the angles kind of get to the extremes. And we can use the blending right here with the factor. So this is perfect because we don't have to duplicate this image around. My first attempt at doing tri-planar mapping created, 3 separate images, and in the case of the scattering, it was 3 of these setups stacked on top of each other, all blended at the very end, and that was super inefficient and super slow. So I'm very happy that I found this setup, and again, thanks to Gabe for that. And then we can just make this into a single group node. So I'll select everything here up to, but not including the image texture, and hit Control G. Then I'll hit Control Tab and rename this Tri-planar blending. Okay, and then I'll hit Tab. We need a couple different inputs to control from the outside. We should be able to control the scale, and we should be able to control the factor, the amount of blending. So I'll call this blending. I'll give it a default of 0. I'll make that the top one. And then for the output here, this really should be a purple little color, little socket. So let's delete that, and then I'll just plug in a vector from anywhere in the graph, just so that it gives it a purple socket, and then we can plug this into the vector now, and there we go. So we can use this anywhere in our big node graph here. So I can actually go ahead and just click the shield icon to make sure that this is saved, even if it doesn't have any users, and go ahead and delete it. And then go to our scatter overlapping node, hit Tab, and then hit Shift A, Group, and Tri-planar blending. So now instead of using the UV coordinates here, I'll just shift and right click and drag all the way through them, and then kind of cut that connection by control and right clicking. And then instead of using the UV, I'll just plug in the vector here. And I'll just set the scale to 1. And then I'll reroute the blending from the triplanar all the way to the group input here. And I'll rename this Tri-planar blending. Okay, so let's give this a try and see if it works. Control Shift Tab to preview it. And this is the overlapping version, so of course it's going to take a little bit to compile. But once that's finished, we have our result, and we can use our triplanar blending just like so, and all of our fancy features like our random location, random rotation, and we can scale this on the x-axis if we want to, or do anything else in 2D. And another benefit is that we can also switch all of our textures back to 2D. So I think, yeah, we changed the noise texture to 3D previously so we could use it with box mapping. But I did several tests, and the triplanar, like the custom triplanar mapping versus the Blender's box mapping, there isn't really any speed increase. In fact, in some cases, the box mapping was actually slower because it used the 3D textures instead of the 2D textures. So for my add-on, I just didn't use box mapping whatsoever because it wasn't really that helpful, and it didn't enable as many features. So we can just set everything to 2D like so, because it's, again, only being projected from the X and the Y. There is no Z axis that's happening here. That'll help speed things up just a little bit. So that's pretty much the gist of how I built these nodes. Now for the add-on, it took a pretty good amount of Python to get this to work, but what I've done is added a bunch of different options so that you can select only what you need and not what you don't, and that way, things aren't going to be slow if you don't need some of these features, because unfortunately in Eevee, Even if something is set to 0 or you're not even using a node, like it's not connected to anything, it'll still calculate it. It'll still slow it down while compiling. So we don't really want that. So I've used Python to kind of remove all the things that we don't need and also add a couple extra features in case you do need them. So let's take a look at that really quick. Again, you can find that once you've installed it in the node menu, all the way down under Voronoi scatter. I right click and assign it to quick favorites so that I can get to it very fast. And then there's also an unscatter option that you can find here to move it back into image texture. So first let's take a look at this just with our concrete texture here. Let's say we have this kind of floating off to the side. All I need to do is hit Q and Voronoi scatter, and now I have a bunch of different options. I can switch between UV or Tri-planar mapping. In this case, I'll go with Tri-planar. I can set the amount of transparency, which in this case does a couple things. If we set it to overlapping, that gives us the full overlapping setup, which we probably don't want, well, especially for this background texture, we definitely don't need it. But we could also set it to simple or none. And none is also going to set this to repeat indefinitely. And that way, if we scale the individual scale down, we're never going to get any gaps. And then simple transparency just gives us a couple other options like alpha clip and things like that, which of course we don't really need if we're not using transparency at all. So none is definitely going to be a little bit faster, and then overlapping is going to be a lot slower. Then we also have pixel interpolation. Since we're using Eevee, we have to use closest. If we're using cycles, then we could use cubic. And then we can also enable edge warp, which we looked at. Let's actually leave texture warp for now. And then we can also enable random color. So then click OK. Then we get our group node here. You can see that this actually renders quite fast. If I were to compare this to the original, I'll just hit Shift D and quickly unscatter this. And let's just give this a normal texture coordinate setup and box map this, flat and box. Set it to generated and increase the scale here. And let's just compare the render times and what it looks like. Okay, so if we just have our normal box mapping setup, and let's set up our camera to right there. So we have our plane as well. And if I hit F12 to render this out, that's going to use cycles. So let's switch back to Eevee just so that we get more accurate comparison for like how much the textures are influencing this. So let's hit F12 and we get 0.33. So very, very fast. But of course, that's just one single image texture, Blender's native box mapping. But if we have all of these different options for our scattering, and let's say we blend our triplanar projection a little bit. Let's say we give it a random location, so it just picks a random spot on this texture to show. Let's give it a random rotation a bit, and we can give it a random scale, even a random hue, random saturation, random value, random cell shape. We give it some edge warp. We change the scale of that just to make sure that we're not getting completely straight lines where these intersect, and then we can also give it some edge blur. So this is a lot more feature packed than normal box mapping. And then if we were to go and hit F12 again, so I'll save this as slot 2. The first one was 0.33. This one is 0.39. So it's not a lot slower. It is, of course, having some impact, but very, very little. This is really, really quick. But then, of course, if you're to use the transparency options, that's going to be a little bit slower. And then if you're going to use the overlapping options, then it's going to be a lot slower. But just this by itself, just for randomizing background textures, is really, really powerful and very fast. But let's take a look at actually scattering around a bunch of things with transparency, just to see how that works. So I'll go ahead and delete this, and let's just delete all this extra junk and kind of move it off to the side. And let me just drag in a bunch of image textures. I'm going to look at a bunch of leaf textures. So we have kind of an ivy leaf here, a fall leaf, and then one that's kind of old, and a branch of 3 little leaves. So let's say we want to just make a pattern out of all of these. Well, with the add-on, it'd be incredibly easy. We just select all 4 of them, hit Q and Voronoi scatter, and I'll leave it on triplanar, but you can set it to UV. It has no impact on performance, really. Then we can set the transparency to simple for now. We'll look at overlapped in a second. Again, pixel interpolation, you'll probably want to keep that at closest for pretty much everything. And then we don't really need the edge warp because we're not really going to be looking at the boundaries between these cells here. But I can enable texture warp, we'll look at that, and then I'll leave on random color. So then I'll click OK here, and very quickly we'll have our setup. And you'll notice that in the areas where we had that Ivy texture where the transparency was just not good. Like you can see that the texture itself is just not a good texture. I got this a very long time ago and I don't even remember where, so it's pretty rough. But that's where the alpha clip really comes in handy, is if we have some of these textures that are maybe not the best quality, we can just turn up the alpha clip and kind of get rid of those artifacts. So that's very handy. We can also set the background if we're working with transparent images, or we can plug in, a texture or whatever we want into there and just kind of pass that right through. But I'll leave this as kind of a black for now. And just like before, we can of course change the scale, individual scale, whatever we need. Give it a random location. The random cell shape will work pretty well with simple. If we change the individual scale to be kind of lower, if we start to bring this up, then you can see that we can kind of see the edges there. But if we have, kind of small textures here, then the random cell shape really works quite well. And we don't even need the random location that much. Just kind of scatter that around. And then we can give it a random rotation here. A little bit of a random scale if we want. But we can also give it a random hue, random saturation, or random value. And then the texture warp is one that I think is interesting. And this is going to kind of give each individual instance its own unique shape. So if we turn this all the way up, you can see that's just kind of warbling it a bit. But if we turn up the scale, then you can see exactly what it's doing. It kind of makes it look like it's underwater or something. But if we set it to, let's say something like 2, and then turn down the value, then we're kind of just pushing each one toward its own unique shape. I'll actually set it to even lower than that. The default of 1 usually works pretty well. But if I just crank this up just a little bit, then not everything is going to be exactly the same. So it just gives a little bit more variation. And here we have a nice, very randomized pattern here for all of these leaves. And again, if we want to undo that, we can just right click and unscatter at any time. Lastly, let's try the overlapping method just to make sure that it works. So I'll select all of these image textures, hit Q, Voronoi, scatter, and let's go with UV mapping this time just to make sure that we test it. Transparency, let's set that to overlapping, and then let's enable all these options just to give us the most intensive test. But even so, it still compiles fairly quickly. Of course, the more images you add, the more comprehensive this gets, the more it's going to slow down. But for something pretty simple like this, it still works quite fast. So of course we need to turn up our alpha clip for that leaf over there. We can increase the pattern scale. But the benefit of this, of course, is that we have the overlap, so we can change the random location a bit and get that nice variation. Change the random rotation here, random scale, and of course randomize this just like all of the others. So in a nutshell, that's the add-on. Again, if you want to get your image textures back out of this, you can just right click and unscatter, and then you'll be good to go. As a reminder, you can find the link to download the Scattershot add-on so that you can do all of this in just one click in the description below. And if you want to learn more about procedural textures and texturing in general and how to use nodes and all of that stuff, then I'd recommend checking out the Fundamentals of Texturing course, which I just recently released. It's super comprehensive and covers everything that you need to know in order to get started UV unwrapping and painting your own textures and using image textures and all of that stuff. I'll put a link to that in the description below too. And I hope you found this video helpful. If you did, definitely subscribe so that you won't miss the next one. See you soon.